Hello, my name is G13. I am from Group 13. I will begin my slide today with introduction fiber reinforced concrete. Concrete and mortar reinforced randomly moved smooth steel fiber ways to investigate and to understand the mechanism fiber of reinforcing. Second, where all the fiber compared to conventional reinforcement in flexure, tension and compression. Third, reinforced concrete, which indicate the steel is fixed into the surface in such a manner that the two materials act together in resisting forces, compressive stress. In a concrete structure based on the reinforcing steel rod, bar or mesh absorb the tensile, and something that gives some pressure inside it.
I am Mong Jia Chong. I'm going to present my part, which is type of fiber reinforced concrete. The first one is steel fiber reinforced concrete. It is a metal reinforcement material. It used to improve the property of material. There are some types of steel fiber, which are round fiber and rectangular steel fiber. The next is polypropylene fiber reinforced concrete. It is an artificial fiber. It decreases the concrete permeability to reduce the water spreading. The characteristic is low density, high crackiness, high stiffness, and good chemical resistance. The next is glass fiber reinforced concrete. It also called as alkali resistant fiber. It gives this unique compound its strength. The characteristic of glass fiber is high strength. Next is polyester fiber. It provides resistance, for example, resistance to the formation of plastic sprinkler crack. Some characteristic is water resistant and good elasticity. Now is carbon fiber. The characteristic is high stiffness and high tensile strength. Next is microsynthetic fiber. It made from polymer to increase the concrete strength. The characteristic is high tensile strength and a high elasticity. Next is microsynthetic fiber. It has strong resistance to the formation of plastic sprinkler crack. Next is natural fiber. It produced by plant and animal, defined as an aggregation cell. The last is cellulose fiber. It made of ester or cellulose ester, can be used to make all kinds of fiber. That's all for me. Thank you.
Advantages and disadvantages. High compressive strength, where is much higher compressive strength instead of other artifact. Second is adequate lastiness. Third, fire and weather resistant, which is sweet during the style of resistant. Fourth, durability because it's more durable. Fifth is economy to mold any shape. Six, cost of maintenance is low. Seven, construction material is economy because structure like footing, piers, and dam is low because it's more economical structure. Disadvantages. There are five sort of disadvantages by using fiber reinforced concrete, which is strength to compressive strength ratio, where the strength is around the 1/10 is compressive strength. Second, final strength not strong enough. Third is from cost is high, where it's used for RC casting usually higher. Fourth, the column section is large, where multi-story building usually use RCC column at this section. Last but not least, shrinkage where it can cause crack. That's all from me. Thank you.
I am Victor Yongwei. Now, I want to present about the mechanical properties of fiber reinforced concrete. I am focusing on three mechanical properties. First, compressive strength. Second, flexural strength. And the third, splitting tensile strength. First, compressive strength. Compressive strength is the maximum load that can withstood by the object. It shall be considered and is important. This is because this is one important property due to the long-term use. The higher the percentage of fiber, the higher the compressive strength of the concrete. From the research, the maximum compressive strength of the concrete is at 1.5% of the steel fiber and 1.0% of the glass fiber. Flexural strength is the maximum bending stress of a model that can be applied to the object before it yields. There are two methods to determine flexural strength. First, 3-point flexural test. Second, 4-point flexural test. From the research, The higher the content of the fiber, the higher the flexural strength of the concrete. This is because the fiber prevents the propagation of the micro cracking and increase the overall cracking resistance. It forms post-cracking ductility and prevent widening of crack. And this indirectly increase the degree of bending of the concrete. Splitting tensile strength is to determine the tensile strength of the concrete by indirectly. As we can see that the figure below shows the concrete cylinder is compressed by the load. After the compression, the load will be cracked and the fiber play an important role to delay the crack formation of the concrete and make it not easily crack. And this increases the tensile strength of the concrete.
Ductility can be defined as the ability of material to sustain plastic deformation under tensile strain before failure. Under the properties of ductility, toughness, strength of the steel fibers, it is commonly influenced by the volume and the type of fiber consumed. According to the research, it's shown that when adding the steel fiber in normal concrete, it will result in the reduction occur in flexural ductility. The ductility ratio of fibrous reinforced concrete will reduce from 50% to 80%. Durability of concrete divided into three parts. First, abrasion resistance. Abrasion resistance can be improved by adding fibers. There are two types of hydraulic structures is used to test abrasion resistance, which are underwater test and waterborne sand test. Second, water absorption and resistant chemical attack such as chloride. The penetration of chloride in reinforced concrete can be induced as the activation of steel rebars and corrosion process of structures that leads to the degradation of concrete structures. Third, the effect of alternating wetting and drying. The degradation of concrete was minor in case of high containing slabs of steel fiber reinforced concrete under wetting drying conditions. Fracture energy can be defined as energy required to open unit area of crack surface. According to David Darwin said that fracture energy is a vital element to increase the behavior of reinforced concrete when the tension is resisted by concrete alone. Hence, it can be concluded as fracture energy is depends on the quantity of fiber applied.
So I'm going to start with application of fiber reinforced concrete. Okay. For the introduction, fiber reinforced concrete can be used for a variety of applications. It is ideally suited for concrete application that require protection from plastic and drying shrinkage. The use of fiber is to improve the durability and increase service life, also reduce construction costs. So the first application, it is main use in structural component for load bearing, such as provide complete structural component, but there are many other applications where the fibers are used to improve the credibility matrix of the material and have a very beneficial effect upon the integrity of structure. The limitation of the fiber reinforced concrete matrix may be either from internal source, for example external support, or common reinforcement. To example here are composite deck and grade slab. So here is the picture of the composite deck and also grade slab. The application of FRC in casting and precasting bridge deck, new construction and repairing dam, tunnel, pit and pile cap. So there are few of application of FRC. Here is the bleeding of concrete, the comparison between fibrous concrete and plain concrete. So I think that's all from me. Thank you.